So, the question at hand that people were arguing over, they were closing in on the number of things physicists could talk about. There was a great debate between a guy named Maxwell and a guy named Faraday. At some point, you should probably... Maxwell decided that the laws of physics were coming to an end. There's only about 5 experiments left that bothered him. And of those 5, he figured he'd just figure those out later on. One of them was a very disturbing one, which involved the fact that light was not behaving itself like it should. What do you mean by that? Light is a wave, or maybe it's a particle. And so now the debate started up between the group that thought light must be a wave and light must be a particle. Okay? Now, what were the arguments? I'll give you 2 arguments there. First one is obvious. Light traveling through space. I'm going to the third one right there. Third one, space. Light travels through space. Light comes from the sun and goes through a bunch of space and then arrives at Earth. If light is a wave, what's the media? And so people said things like space or ether. What's ether? Ether's a stuff that light shakes. We don't know where it is, but it's ether. We're going to call it ether. Okay? Ethernet comes from that idea. The second argument is this. Can you see around corners? Okay, so if I go out in the hallway and I keep talking to you, you can hear my voice, can't you?
Yeah, I can hear them.
How many fingers am I holding up?
7.
Bro, I can honestly kind of see his fingers. Look through that.
Oh
my god.
Why can't you see the number of fingers I'm holding up in the hall? You can hear me talking. If I had water in the floor of this room, 3 inches deep, all the way out in the hallway, and I started jumping up and down in the hallway, you could tell I was jumping up and down. Tell how fast I was jumping up and down. I hold up fingers, you got nothing. If light's a wave, it should hit that doorway and spread out in this room. You should see everything around the corner, which would be a very weird thing. And since it feels like a very weird thing, then light cannot be a wave. Last but not least, they didn't even have lasers back then. They used something called a single slit. Now, as I'm showing you laser lights, never look back towards a laser. It will blind part of your vision spectrum. You'll probably never know. That's it. Look back at the laser there, Mr. Wolf. That's what I just told you not to do.
Oh, I didn't know where she was.
This sounds like a really cool laser. The other reason why I say don't look backwards is it's not as cool laser as you think it is. You guys are imagining this thing that's humming. It's basically the same thing you can find at the drugstore. There's a laser on that front left wall.
I want to look back so bad.
Now, if light's a wave, how can I make a dot? Can sound make a dot?
No.
Can water waves make a dot?
Yes.
Like, that's so weird.
Water waves are traveling towards the front wall. They spread out all over the place, right? Waves spread out. That is making a dot. Lasers and single slits make dots. So therefore, light has to be a particle.
So it's not a wave.
Not a wave.
What's a particle?
What's a double slit?
A particle is like a baseball, a tennis ball. I need a tennis ball for my next thing anyways. Let's talk about tennis ball. So the people that believe this argued that light must in fact be like a tennis ball. And in fact, light, whatever it was, traveled like a particle. And the reason why you can see light on the floor here is light is doing what? It's hitting objects, bouncing off and coming to your eye. That you can see, but you can't see
Sound.
around the corner like a sound. And so something's wrong. Now, if that was the sum and total of the argument, we'd be done with this and we would be teaching in the waves chapter, would we? So there must be another argument. The other argument, I can give you 3 examples for that side. 1, let's readdress light around the corners. If you're careful, and unfortunately I don't have a dark enough room anymore. I used to have a nice dark room, which was, I hated 99 days out of the year, but one day a year was great. if you were to look in a darkened room, and you should do this, go into the bathroom, close the door, turn off the lights, you'll see that this area right here is lit. Right here, right against this door. When you close the door, for some reason light will make an image here. If you notice on the floor, yes, it's a straight line, there's also kind of a haze that comes on the edge. It doesn't quite go straight like a particle should. In fact, what it acts like is as if light had really small waves and was only interfering right along the doorway, so a very small amount of it. Like light somehow separated, like not normal waves. But it does bend around the corner. And yes, because it's a very narrow band, you're never going to see how many fingers I'm holding up. But it does bend slightly around corners. But that's not good enough. I'll give you two more. The next one has to do with slits. If I take a wave in the ocean or in a lake, and I run it through a series of concrete barriers, I do it like this. I got concrete barriers like this. What's going to happen when a wave hits this? It's going to hit this and make little waves like this, right? You guys all know this, right? Waves coming in here, concrete barriers are going to look like that, right? And they're going to go like this, and then they're going to get bigger as they keep going out, right? You guys know this? Am I making? No, you have no idea what I'm talking about. You've never seen waves going through pieces of concrete or anything?
No.
Never in your life.
Why would I do that?
Resident, what are we doing from the side?
Top down. You're looking for the top. You got waves coming towards the shore, right? If you have things that are sitting blocking it,
Oh, okay.
when they try to go through this narrow gap, they change into little tiny waves on the far side that look something like that.
Yeah.
Okay, I got all yeahs except for from Eppolito. All right, well, as long as there's only one that doesn't know, you need to go outside and play in the water a little bit.
These are the things, the waves are coming this way. So it's gonna be like
They get stopped here by these, and the wave kind of bows up in the middle, and then it starts coming through. Now, if it bows up in the middle, then you're going to get this pattern, which is interesting because it leads to places where they go up and they go down, right? You get these little spiky patterns. And so if I were to put a blank beach over here, there'd be places where the water's kind of spikes, and there's other places where it doesn't spike. So if I have a slit, if I have just waves coming in, there's a tendency for them to make higher points and lower points out there in the water. If I take that beam of light I showed you earlier, and I put a set of slits in front of it,
Oh, it's separate.
it should separate and not just be a dot on the wall with little dots, it should spread out. Because notice these waves do what? They spread out. They don't just glow where the barrier is. They're going to spread out all over the place, right? They're going to suddenly become lots of dots all the way out there, lots of high points all the way out there. So, let's see if I can do that.
Yeah, I think we're. Oh, we're not.
Oh, wait, wait.
So here's my
I'm not looking.
laser pointed at the same wall. You guys got there?
Yeah.
Okay, so laser. Now I'm going to put in front of a series of slits. Now, if it's a particle, all I do is make a couple dots on there, right? But if it's a wave, I'm going to do it with a lot of dots all over the place. Move my laser back and forth so you can see all the dots.
Wow.
Now, what's causing those?
Don't know.
The waves as they go through there are blowing out like they would as a normal wave. That makes no sense unless it happens to be a wave. A tennis ball is not going to go through a slit, and suddenly go, and over there. Right? It's actually going to narrow down where it hits the back. Now, last but not least, polarization, which I guess we'll do next time because you guys are already packing up your stuff. Okay, so for homework, you have that worksheet to do. We'll pick up light next time. Yes. You have, I give you a review worksheet. It's on the stool. Remember, the review worksheet's on the stool. Pick that up on your way out the door. We'll pick up the light conversation next time.
Rosie, would you like to keep this so you don't have to keep printing them?